Now for the others, beta, correlation, R squared, we subtract and multiply as well, except for here you notice there's an X and a Y. There's two data series. So we take X, individual X minus the average, individual Y minus the average, and we multiply those together. And so when we do that, we can get negative numbers, because if X is generally above its average, when Y is generally below its average, then you will get negative numbers. If X and Y are generally above their average at the same time and below their averages at the same time, you'll get a positive number. And so thinking about diversification with correlation, we like low or even negative correlation because that means more diversification benefit. Why? Well, because one thing we own, when it's doing badly, it's below its average. The other thing we own tends to be doing well. It's above its average, so it provides that diversification. We then add up all those multiplications and divide by n, so that just means we take the average. In Excel for standard deviation, if you use the STDEVP function, you're dividing by n. The P stands for population. In Excel, if you use the STDEV function, you're not dividing by n, but by n minus 1. There's 1 degree of freedom. So generally in finance, we use the STDEVP, even though statistically we probably should be viewing it as a sample size. It just makes the math a lot easier to use the population standard deviation. Once we get that last part, then we're going to divide or take the square root. So beta, correlation, R squared, we divide by something. With standard deviation, we take the square root. So for correlation, R squared, we divide by the standard deviation of X times the standard deviation of Y. For beta, we take the standard deviation of market squared. So if X is an individual stock and Y is the market, then we'll take the standard deviation of the market times the standard deviation of market. And then for standard deviation, we take the average from C and just take the square root. You notice these assume symmetry and normal distributions. And the reason it's important to know these formulas is that our theories in finance are embedded in our formulas. So something I strongly recommend that you try, and it's very easy to do, is go to Yahoo Finance and just put in a stock. I'll put in Apple, AAPL. I'll click on historical prices, similar to what you did for homework 9 with doing your beta. I'll bring in weekly data, and I'll come down to the bottom of the page and say I want to bring that over to Excel. And so I encourage you to be able to do this at home so that you really can think about what these formulas are doing. So there's my Apple stock. All I need is the adjusted close, so I'm going to delete all those other columns and just do Apple. And then I need something to compare it to, so I'm going to compare it to the market. So I'm going to go back to Yahoo Finance, find the S&P 500, do historical prices, and do that weekly as well. Go down to the bottom of the page, pull it into Excel. Again, get rid of everything but the adjusted close. So very, very similar to what we did with beta. I'll copy all of that over to the other Excel so I can have them right next to each other. So there's Apple, there's the S&P 500. Let me expand out the dates. I'll use my end key and down arrow to get me to the bottom of Apple. Remember with Apple or any company, when we're using adjusted close, we don't use data when their adjusted close price gets adjusted down below $1. So I'm going to go to the very last date in 1987. I'm going to delete everything else. And so now I have Apple's prices in the S&P 500 for the same dates, 12/28/87, 3/3/30/2015. I can delete the dates here. And then I'm going to highlight the whole thing, do my Shift Control down arrow, right. I'm going to do data and sort it A to Z, so I start with the earliest to latest. Let me copy these titles over, and I'm going to have my returns. My return for Apple is the $1.24 divided by the $1.30 minus 1. So that means on that first period, they had a pretty significant loss. I can copy that over to the S&P. Copy these down. And There's all my returns. I'm going to fix my formatting here so everything looks similar. You can see some big days for Apple where they're down 10%, but so is the market. They're up a bunch, the market's up a little bit. So what does this mean? So let's first calculate the average for Apple and S&P. So the average is just equal average, and I'll go find the returns for Apple. There's its weekly average, and then I can copy it over to returns for S&P. Let me do the standard deviation for Apple, equal STDEVP. I can copy that over for Apple and let me do the beta. That's equal slope is the formula you use. You highlight Apple's. You highlight the S&P 500. So there's Apple's beta 1.06. There isn't a beta for the market. It's 1, so we don't need to do that. Let's do correlation. We'll do equal CORREL in Excel. You highlight Apple. You highlight the S&P 500. Here's our correlation. Obviously they're positively correlated. And then the R squared, the easiest of all, is you just take the correlation times itself, and that's what R squared is. And we usually express R squared as a percent. So what can you do with this? Well, I recommend that you see if you can't produce this whole thing yourself. So I'm going to move this over. And so remember standard deviation, I just say how far is Apple from its average. So I take each point on average, each point on Apple and subtract its average. And I copy that down. Remember the second step, so the first thing is how far are you? So xi minus x bar. The second thing I do is I square this. So that times itself. Copy that down. The next thing I do is I take the average of that, or I sum it and divide by n. The average of that is 0.0369, and then I take the square root of that, I raise it to the 0.5, and I get 6.08, which is the exact number over here. So this is what I say, if you can do it in Excel like this, you truly understand it. So do it step by step. Take the difference, square the difference, take the average of those square differences, take the square root of that, that's standard deviation. And you should know it just that quickly, it should be that easy. Same thing with beta, except for now with beta, give myself a little bit more room. So I'll move this up. With beta, we have xi minus x bar. So now I'm going to do yi minus y bar, where y is the market. So I take each period on the market minus its average. Make sure to lock it in. I'll copy that down. I then I multiply the differences. So I got the difference for Apple times the difference for the market. Copy that down. I then take the average of that, of those differences. And there's actually a term for the average of the differences. When you're doing correlation and beta and R squared, the average of those differences is known as covariance. So this is actually the covariance. And I can even show that to you. I'll do equal covar, and I'll do the returns for Apple, comma, and the returns for the market. And I should, if I did it correctly, get the exact same number, and I do. And then the very last step for beta, is to take the covariance and divide it by the standard deviation of the market. squared. So when I do that, I get a beta. You can see the beta I get is exactly the same as the beta that Excel gives me. When I do correlation, correlation is the covariance divided by the standard deviation of Apple times the standard deviation of the market. You can see I get the same 0.4 I got over here, and then of course hard squared is just that. So it may seem tedious, but you can see if you do this, you truly understand what you're doing when it comes to understanding these ratios. And I also said that these are very sensitive outliers. One of the advantages of doing this like this, all spelled out, you can actually go and find those outliers. You know, you might say, what's the maximum and what's the minimum in this column, and see how much of an impact it's having. Because sometimes one day can really skew the results. You might say, wow, that one day of negative 12.67%, that's a really huge day. Or maybe you had a day that was 40% or 50%. Here's 2 days that are 17. If you find one day that's just extremely huge versus the others, you might test and see what happens if I take that one day, or these are weeks, of course. So what if I took that 1 week out? How much would it impact my standard deviation, my beta, my correlation, my R squared? Given that you have these outliers, sometimes we have to make the decision, do we leave the outlier in or take the outlier out? I'll save this and put it out there on Blackboard so you can see how I did it. But I really encourage you, with just a blank spreadsheet in Excel, to be able to bring in the data on a stock, bring in this data on the market, and manually calculate standard deviation, beta, correlation, R squared. Very important formulas, and because they're very important formulas, we should really understand them, because the theory that we're dealing with, especially here related to risk, where we define risk, is how far something can be from its expected value. It's very important to understand those formulas and not just be plugging them into Excel or plugging them into calculators. So here's the math we're going to be handling here. It was the value at risk. So now that we know what standard deviation is, remember those numbers. Here's the formula we're going to be using quite extensively. Value at risk equals the mean, or the average. We use the term mean for average, but we also use the term expected value, which essentially means the average is that midpoint of the distribution. It's the term that we most expect. At least 50% of the time we expect our number to be higher than that, 50% of the time lower than that. So it's right in the middle. So the mean minus the number of standard deviations, we'll talk about that, where do we get that number, times the standard deviation. And we do this formula, it will tell us the loss that we expect out of probability associated with the number of standard deviations that we get. We need a normal table, so let me show you a normal table. I can get rid of this file. So we need a normal table. Let me do File, New. I'll do a blank firm. And the way the normal table works, we start with 0, and down the side we add 0.1. We just do that all the way down, and you can go, I don't know, down to 4, I guess. Just go, 4 is probably more than far enough. So we'll stop at 4. You'll see why in a minute. I'm going to change my formatting, so I'll just have 1 decimal. And then across the top, we'll also start with 0. And then here we're not going to add 0.1, but 0.01. And here we only need to go across